Okay, so now we're just being asked to verify for 3b, verify that this is a right triangle. And to do that, we're just going to check that it satisfies the Pythagorean theorem. So sorry, we're going to use the same letters to refer to something that's completely different, but this is how it's normally written, the Pythagorean theorem, that if we're working with a right triangle, then we have a squared plus b squared is equal to c squared, where c is the hypotenuse and a and b are sides, and that is a beautiful little triangle there. That tells us that this is a right angle right here, or that this is a right triangle, and if this is a right triangle, then we know that a squared plus b squared is equal to c squared. So now we're just checking if this right here is a right triangle. We're checking to make sure that it is. So I'm going to call so here we're just going to substitute in the distance between A and C, and here we're going to substitute in the distance between B and C, and here this is the hypotenuse, so this is the only one we don't have freedom in picking, and we're going to substitute in the distance, and square that guy, distance between A and B, and that's got to be squared. So if this holds, then we know it's a right triangle, and guess what? The distance between A and C from our previous question is root 13, and we're squaring that, plus 1, and we're squaring that, and it's going to stay the same. Is this equal to root 14 all squared? So squaring the root gets rid of it. That stays the same, and we get 13 plus 1 is equal to 14, which is true. Therefore, we have ourselves a nice little right triangle. Also, it's worth noting that this generalization of this is how we get the distance formula in any dimension that we used in